Hello and welcome. This is Cambridge O-Level Physics Paper 4, alternate to practical. This is May-June 2022 exam. The subject code is 5054 and this is variant 2 of this exam. Let's start. Question number 1. It says a student determines the thickness of a glass in a test tube. Part A. The student uses a ruler and two wooden blocks to help him measure the external diameter of the test tube. Describe with the help or with the aid of a diagram how the student determines an accurate value of D. So what a student can do, student can say put wooden blocks on a table. So this is the side view of the of our arrangement. So this is say the table floor or a straight floor. So he places the test tube something like this. This is the round edge of the test tube. And then again, place the other wooden block like this. So this is your wooden block. This is your wooden block. And then aligns the ruler along the edge like this. And say this is your ruler. Then measure the value here. So let's call it as D1. Measure the value over here. This called D2. This is say, for example, 0 centimeter of the scale. This is, for example, 30 centimeter of the scale. Something like this. So this is the way in which your ruler is placed. So just simply measure the D by taking the difference between D2 minus D1. This will give the value of D. Just change the location of the ruler and measure the value. So let's try to write it down. So it says place the inverted test tube between the wooden blocks on a table as shown. Align the ruler across the edges of the blocks and record values of D1 and D2 again as shown. Calculate the diameter D as D2 minus D1. Then repeat the experiment with different stations of ruler and take average. Okay, this will give you a good or help you determine good and accurate value of the diameter. Then part B, it says the student clamps a test tube in a stand, fills the measuring cylinder to 100 centimeter cube mark of the water, pour some water from the measuring cylinder to the test tube. Then it says the arrangement of apparatus is shown. The test tube containing water is also shown. Measure number 1, the height of the water in the full size test tube. So again, this is the full size test tube we are given. So if we are going to measure the height of this on our actual exam, this will come out to be something 3.2 centimeters. And we'll also measure the value of D, and this value comes out to be approximately 2.5 centimeter. Okay. So once we have measured these values, it says measure the height h of the water in full size test tube in figure 1.1. Record h in centimeters to nearest millimeter in the second row of the table. So we have already measured it into the nearest millimeter. So we'll go to the table 1 and record. So height is 3.2 centimeters. Okay. Then next part, it says figure 1.2 shows volume VR of the water remaining in the measuring cylinder. Okay. Record value of VR in table 1. Okay. Then it says calculate volume V of water in the test tube. So first of all, we'll record this value. This volume VR is equal to 89 centimeter cube. So let's record this and we'll measure it as 89. So 89 centimeter cube over here. Then it says calculate volume V of water in the test tube. So this is our cylinder. Cylinder was completely filled to 100 centimeter cube. Now the volume is 89 centimeter cube. So if we are going to subtract the both values, so volume in test tube will be equal to 11 centimeter cube. So record the value in V table 1.1. Okay. So volume will be 11 centimeter cube. Okay. So we're done with part C. Now going to part D. It says the student adds more water from the measuring cylinder into the test tube, measures and records the new value of H and VR in the table, repeats the procedure for 3 more values of H and VR. The student results are shown in the table 1.1. Okay, so the table is shown. So it says on the grid provided, plot a graph of V or volume on the y-axis and H on the x-axis. So remember, y-axis, this is x-axis. On the x-axis we are plotting H, and on the y-axis we are plotting volume, and volume is in centimeter cube. It is V, and minimum volume is 11, maximum volume is 11 to 53. Height is between 3.2 to 14.2. So we have to make sure that all these values are on the scale, both axes from 0 and 0. Okay. So let's say we have this scale with us. So remember, our H is going maximum up to, so again, first of all, label the same. This is our x-axis. Remember, this is our y-axis. So there are points for labeling the axis. So x-axis, so remember this is, so now this is rough work. So this is rough work I'm doing here. So on our x-axis, the maximum value is 53. On our y-axis, the maximum value is 89. Okay. Oh, sorry. So maximum volume is, so on the x, the maximum height is, sorry. So the maximum height is say 14.2, and on y, the maximum volume is 53. Okay, so we have 1, 2, 3, 4, 5, something like that. So let's say 10, 20, 30, 40, and 50. So this will give us a good utilization of the grid we are given, or the graph we are given, as well as it will give us all the values in the table. And then on the side 1, 2, 3, 4, 5, 6, 7. So there are 7. So let's do 2, 4, 6, 8, 10, 12, and 14. So now we have a good scale with us. So let's plot these points. So plotting these points and making a best fit straight line. So first point is 3.2 and 11. So 3, 3.2 and 11. So this is our first point. Okay, so this is our first point. Then our second point is 5.6 and 21. 5, 20, 1, 2, 4, 6. So 5.6 somewhere here. Oh, first point is gone. First point was 3.2 and 11. Then we have 8.9 and 34. 8.9, almost 9, and 32, 3, 4. So somewhere here. So somewhere here is our point. Then we have 12.5 and 46. 12, 40, 13, 12.5, 5, somewhere here. Okay. And then we have 14.2 and 53. So 14, 52, 14, somewhere here. Uh-oh. Previous point is gone. So previous one was 12.5 and 46. So 12, 12.5, 45, 46. Okay. So 12, 14.2 and so now let's try and draw a best fit straight line. I'll draw it with a blue line. So make sure it will pass through 0, 0. Again, you use a ruler that is given to and draw a line. Make sure between these points. Make sure this passes through all these points. So some of them will be on the line, some of them will not on the line. Make sure you have maximum number of points on the line. And the second thing, if some of the points are below the line, make sure try as much as possible that you have at least equal number of points above the line. So that will give you a best fit straight line. Okay, so this you will be able to draw in a much better manner than me when you will be drawing it on your exam. Unfortunately, I don't have a ruler or the digital ruler that will go, but it will look something much better than this on the actual paper. So moving ahead, it says part E, calculate the gradient M on your line. So remember, say if this is your line, now I'm using say blackman. So you have to find out a gradient, find 2 points, say let's say A and let's say B on your graph. Find out the values of these points. So for example, when I made this line, my point A was 4.4 on the x-axis and 17 on the y-axis. My point B was 10.6 on the x-axis and 40 on the y-axis. So these were my 2 points. So on the slope, it will be actually the change in y and change in x. So so calculate M. So M, say let's say point, I call it A. Point A was 4.4 and 17. So remember, you have to select these points on the graph, and these points should not be the ones that are given on the table. So you have another point, point B, slope is equal to, let's say, M. M is equal to, so point change delta, it is delta y by delta x. So delta y is 40 minus 17 divided by 10.6 minus 4.4. Or remember the formula, x y2 minus y1 over x2 minus x1 for slope M between any 2 points, let's say A x1, y1, B x2, y2. Remember, this formula is for the slope. So if you are going to use this, so this will come out to be 23 divided by 6.3, it equals to 3.71. So remember the units on the y-axis, we have volume, centimeter cube. On the x, we have centimeter. So this is change in centimeter cube, volume divided by centimeter. So this is 3.71 centimeter square. Or if this is the actual value, so volume, and in centimeter, yes. So our units are good. So the slope value, it will be 3.71 in centimeter square. So coming back, it says if the test tube is a perfect cylinder, the internal diameter T is given by the equation 4m over pi. Use your value of m to calculate the value of D. So again, D is equal to 4 multiplied by 3.71, divided it by pi, and take the under root. So this value comes out to be 2.17 centimeter. So the value is 2.17. Okay. So this is how you put your or calculate your value. Then in part D or part F, it says your value of D is approximate. Okay. Number one, state one difficulty in measuring the value or of height h of the water in the test tube and suggest how it is difficult to and how this difficulty can be overcome. So difficulty would be aligning the ruler with the curved bottom of the test tube. So for example, uh, if you are measuring it here, so the ruler will be aligned with the bottom of the test tube. It would be difficult to measure this value, especially if you are aligning it with this, or your ruler is over here. This will be difficult to find out this value and this value to find out this diameter. So, and another, so, but again, with the curved diameter, we are more inclined towards finding this value of h. So one difficulty in measuring the height h. So if height h is this, so this is another way. So this curved surface, remember curved surface, we are not so that difficulty which I was talking earlier, that was in fact the difficulty about D. So that we are not concerned here. So we are basically concerned about measuring this edge. So aligning the edge of the ruler with this curved bottom surface will be a challenge. So this will be another. So this is the key issue in this measurement. So difficulty will be aligning the ruler with curved bottom surface of the test tube will be a challenge. So suggestion is you can say clamp the ruler as well. Clamp the ruler and make it close to the test tube as possible. So another way is use another clamp or use another clamp to use another clamp to clamp the ruler and make it close to the test tube as possible. Okay, this will give you much better or more aligned or more accurate measurement. Uh, then part 2, it says suggest another reason why you calculated value of D is only approximate. So the measurement of the value or measurement accuracy is an approximate because the value we are measuring is only up to centimeter cube, and that is because of the accuracy of the measuring cylinder. And then we have some non-uniformities on the diameter of the test tube as well, so that will also give us some approximate value. So number one case, suggest a reason. We can say one reason can be the measurement accuracy of cylinder is up to 1 centimeter cube, and that is a reason of inaccuracy. Number two, you can say the imperfections or Perfections of glass tubes results in non-uniform diameter values. Okay. Yeah. So this is how you can answer this question. So moving ahead, part G, it says measure the external diameter D of the full size test tube. So remember, we have measured it earlier. So, and we measured it out to be 2.5 or 2.4 as per. So we measured it to be 2.5 centimeter, or you can say 2.4 centimeter as per your marking scheme. So it's fine to use any of these values. So I'll go with the 2.5 centimeter, which I have used. So again, it says use your answer in part E3, and my value of E3 is 2.17. And part G1 to calculate the thickness of the glass. So remember, we have measured the outside diameter. So outside the thickness the glass is outside diameter minus the inside diameter D. So that will give you the thickness. So this value outside diameter, we have made 2.5 minus 2.17. So this comes out to be 0.326. And remember, this thickness is actually the half of this. So we also have to divide it by 2. So divided it by 2. And this comes out to be 0.163 centimeters, or a good answer is 0.16 centimeter. So remember, if we have to see it like this, so our volume calculations gave us this D, our physical measurements gave us this value of diameter. So, and the thickness, this is the thickness. So in the complete diameter, we have complete D is equal to D plus 2 times thickness. So if we have to measure thickness, this is actually equal to D minus small d divided by 2. So this is how this formula is derived. So my answer, 0.16 centimeters as the final value. So moving ahead, it says question number 2. A student investigates the cooling of a hot water in a beaker. The student measures the room temperature before starting the investigation. The room temperature is 24 degrees centigrade. So the student, number 1, pours 150 centimeter cube of water into the beaker. Number 2, places a thermometer into the hot water. Number 3, waits for 30 seconds. He then reads the initial temperature of the hot water and starts the stopwatch, records the temperature theta of the hot water every 60 seconds for 300 seconds. The student readings are shown in the table below. Okay, table are given. So then it says suggest why the student waits 30 seconds before the initial before reading the initial temperature of the hot water. So remember, this is water. It takes some time for the water to, or the temperature to settle to a uniform value, and that is why the student is waiting. So it says this allows the thermometer reading to settle to a specific value. Okay. Then it says calculate the average rate of cooling R of water during the first 60 seconds. Use the equation theta 0, theta 60, where theta 0 is the temperature of the hot water at the start, theta 60 is the temperature of the hot water at 60 seconds. So this is the value. So theta 0 is, so R1 will be equal to theta 0 as 89.5 minus 83 divided by 60, and this comes out to be 0.1083 degrees per second. So my answer, up to 3 decimal places I can go. So 0.108 degrees per centimeter. Then it says calculate the average rate of cooling R2 of the hot water between 240 and 300. So this is the again. So average rate R2 would be 69 minus 66 divided by 60. So it will be 3 by 60. This comes out to be 0.05 degrees centigrade per second. So 0.05 degrees centigrade per second will be my choice. Then part C, it says use the values calculated in part B. Describe how rate of cooling of hot water changes as the hot water cools. So rate of cooling decreases as the water cools down. So rate of cooling decreases. Remember, we are talking with time as the water cools down. Okay. Then says at the end of the investigation, the student leaves the water in the beaker. Predict the final temperature of the water 2 hours later. So that temperature shall be room temperature. Or for example, the normal room temperature is standard room temperature 24 degrees centigrade. So we can also say 24 degrees centigrade. It's part E. It says suggest how the student ensures the temperature readings are as accurate as possible. So there are multiple reasons you can write. One reason is stirring the beaker before reading. Number two, using digital thermometer that provides better accuracy. Also, avoid parallax error. While measurement from thermometer you're using, so make sure your eye is 90-degree with the scale. Then or make sure to immerse 1/3 of thermometer in the beaker for measurements. So make sure you have the bulb of the thermometer and 1/3 of the length of the thermometer immersed inside water while you're measuring. So any of these 4 reasons you can write, and I think you will be able to get a complete credit for your answer. So moving on, question number 3, it says three students A, B, C measure the speed of air. Student A and B stand at opposite ends of football pitch. Student A strike 2 large blocks of wood together. Student B starts stopwatch, and then she sees the blocks hit together. When she sees the blocks hit each other and stops the stopwatch when she hears the sound. The student repeats this procedure twice. The student C measures the distance between students A and B. The times recorded are 0.45, 0.41, and 0.51. Calculate the average value T. Give your answer to 2 significant figures. So average value T, average is 0.45 plus 0.41 plus 0.51 divided by 3. So the average comes out to be 0.456666. So up to 3 decimal places, 0.456 seconds, and two significant figures, 0.46 seconds. So time would be 0.46 seconds. Then part B, it says distance between students A and B is 119 meters. Suggest a device that can be used for measuring the distance. So you can use a laser range finder, measuring tape, a long one for this matter. Then it says calculate value of V, the speed of sound in the air. Use the equation V equals to D by T. So we have value V as distance 119 meters and time 0.46 seconds. So this comes out to be 258.6956 meters per second. Up to two significant figures, we can say 258.6, not 269.5. Again, yeah, let's go with this value. So, and then it says suggest one reason why the calculated value in V2 for the speed of sounds is only approximate. So it can be approximate because we can have first reason be the human reaction error in measurements of time causes a delay. Or you can say the inaccurate measurement of distance. So if we are able to, so we need to measure the straight line distance between. So if there is some inaccuracy in measurement of this distance, this will also result in inaccurate measure or an approximate value of speed of sound. So moving ahead, question number 4, it says, or the last question for this exam, say the student investigates how the resistance of a filament lamp changes when the current through it is varied. The student connects the circuit as shown in figure 4.1. The student has connected the circuit incorrectly. In the space below, redraw the circuit with a voltmeter and ammeter connected in the correct position. So remember, in the circuit, the ammeter is in, this is in parallel. This is incorrect. The voltmeter is in parallel. This is correct. Okay, but it is against the. So we need to find the resistance of the filament lamp. So this is your lamp. This is your variable resistance. So voltmeter, although is in, so variable resistance. So voltmeter, although it is in parallel, but it is placed against the wrong device. It should be placed here in parallel against the lamp, and this ammeter should be in series. Okay, so the actual circuit should look something like this. So I'm redrawing it in blue, redrawing it here. So 1, 1, this is my ammeter. This comes as my lamp. This comes as my variable resistor. This as my switch. And a voltmeter here will give me the value against lamp and the value. So the correct circuit would look something like this. Okay, so the voltmeter in parallel across the lamp will give you the voltage across the lamp. Ammeter in series will give you the value of current passing through the lamp. And if you have the value of voltage and current across the lamp, you will easily find the resistor So remember, resistance equals to V by, or using Ohm's law. Okay. So moving ahead, part B, it says the switch is closed in corrected circuit. The student observes the lamp does not appear to light up. The filament of the lamp is not broken and battery is not run down. What observation does the student make to confirm quickly the filament of the lamp is not broken? So the only reason is that if in this circuit your variable resistance is at so maximum value, so our variable, if this is at maximum value, it is limiting the current flow through this device. If you vary this resistance to the lower value, you'll automatically see the lamp lighting up. So, uh-oh. So it says, part B1, what observation does the student make to quickly confirm that the filament of the lamp is not broken? So, very interestingly, what we can see. So if what we can see is that if there is some sort of deflection across the ammeter, so it means that if there is some deflection, it means that some current flows through the circuit, but it is not glowing because the variable or resistance is at maxed out. This may be the reason. So the observation over here is the deflection on the ammeter. So we can say the deflection on the ammeter shows the circuit is complete or the filament is intact. And then suggest why the lamp does not appear to light. The variable resistance is maxed out or is at high resistance value, as I've said earlier. So the variable resistance is at its highest value, thus limiting the current through the filament of lamp, causing it not to glow, or which is not enough to light up the bulb. So this is how you write down this answer. And since this is the last question, so I hope you have enjoyed this, and wish you best of luck for your exams. And if you have any questions, please feel free to write them down in the comment section, and looking forward to them. And if you have any suggestions for improvement, please also feel free to mention them. So thank you very much. Take care.